Okay, in this video, I'm going to be going over the first question on the assignment that you're going to be working on. And of course, it's all about the features of the rational functions, okay, that we have talked about previously. So here's this first function. And you can, graph this in the Desmos graphing calculator, and you can find a lot of that information just from that, okay? I'll show you how to do some things by hand in this video. But the first thing you have to do is factor this. So after factoring the function, we see that y equals x minus 5 divided by x plus 4. Looking here, as I factored it, you can see that there's a common factor in the numerator and the denominator of x plus 3. So obviously we canceled that out in order to get the final simplified version of the function. But this common factor of x plus 3 is where we will find our whole. Okay, if we set x plus 3 equal to 0, then we understand that x equals negative 3. Well, that's what I mean. The x value of the whole is negative 3. Now, if you want to determine the y value, you just plug negative 3 in here for x in the numerator and x in the denominator of this one specifically, and you will determine what the y value is. So you can see I have the work here. If you just in the numerator, negative 3 minus 5 is negative 8 over 1, which is negative 8. So at negative 3, negative 8, this function has a whole. I'm going to go ahead and identify that here at negative 3, negative 8. Okay. Now, the x-intercept, you can look at that on your graph if you graph it, or I've taught you that you can set the numerator equal to 0 to find the x-intercept, and the numerator is x minus 5. So, of course, the x-intercept is going to be at positive 5, sorry, at positive 5. So this will be the x-intercept here at 5, 0. Okay. And the y-intercept, that's a little bit more involved. That's where you just plug, you plug 0 in here for x and 0 in here for x. So 0 minus 5 is negative 5, and 0 plus 4 is 4. So it's really just negative 5 over 4, which is negative 1 1/4. So the y-intercept is here at like negative 1 1/4. So when x is 0, y is negative 1.25. Okay. So now we need to take a look at the asymptotes, the vertical asymptote and the horizontal asymptote. So the vertical asymptote, remember, that's when we set the denominator equal to 0. So if our denominator is x plus 4 and we set that equal to 0, then x equals negative 4. So we have a vertical asymptote at x equals negative 4, which is just here. Okay, and then the horizontal asymptote, the way that we determine the horizontal asymptote, remember, it has to do with the degree of the numerator and denominator, either in the original or the simplified version, but the degree is the same, okay? And when the degree is the same, you use the coefficients. And in this example, the coefficient is 1 over 1, which is 1. So that just means our horizontal asymptote is at y equals 1. So we know we have this horizontal asymptote. All right. So we pretty much have all the parts. When you graph, or if you look at the graph in Desmos, you see that it looks like this, okay? I'm going to show that there's a hole here at negative 3, negative 8, and then it goes through the x and y intercept, and it looks like that, okay? The last thing I want to make sure that you are aware of, though, is that how we identify the domain and the range, okay? So the domain is all real numbers except for it doesn't have a negative 4 value, but it also doesn't have a negative 3 value, this hole right here. So when we are determining, or when we are representing the domain, we have to be sure to include the vertical asymptote and the x value of the hole. So on this one, we're going negative infinity to negative 4, the vertical asymptote, and then from the vertical asymptote only to negative 3, because there's a hole here at negative 3 on the x value, and then from negative 3 to positive infinity. The range is the same. We come from negative infinity up to, and then we get to our hole, which is at negative 8. Then from negative 8, we have all real numbers except for when we get to 1, which is our horizontal asymptote, and then from 1 to technically up here positive at infinity. So that's how you identify the domain and range. Okay, so that's a kind of a quick review that you can use to help. The rest of the assignment, it's very similar except for you have to do the factoring, and some of the factoring is a little different. Remember, this one's the difference of two squares, so x plus 4, x minus 4 type thing. Then this one, when you factor this one, it's a little bit more challenging because the a value is greater than 1. It's a 2, so don't forget what to do there. And then finally on this last one, this one here is just greatest common factor. Factor out the greatest common factor, and this again is the difference of two squares. Okay, just complete that assignment in class and turn